have this. It's a nice little bootloader that loads our kernel, and right now our kernel, what it does is it just prints a horizontal line, basically. And what we're going to do today is we're first going to skim through this uh, protocol specification of the Limine boot protocol and try to go over some of the details that we might need later. And then what we're going to do is um, we're basically gonna uh, uh, write code to print stuff to the screen. So we're going to like come up with a hello world kernel basically. Um, First things first, let's just so I skimmed over this document a while back, and it seems that the Limine protocol, like the bootloader, does a lot of things already for us. And so let's just begin. Um, so one thing we need to uh, understand is that the way the protocol works is it is centered around the concept of request and response. And so apparently they are called features. And if we need to request something from the bootloader, so the bootloader itself will like it provides these features, but in order to like get them, we first need to request that stuff with the bootloader. And the way we do that is using two structures, the request and the response. So um, here's an example. We do a request, mm, and then the response will have uh, wait, what is this? Ah, so like here is it's just showing what kind of members would a response request and response would have. But uh, basically, uh, if we need to like get the frame buffer, then we do a frame buffer request, and then we'll get a response. And the bootloader will set up the requested feature and then provide us a pointer to the response. Basically, yeah, it says that the field is filled in by the bootloader at load time. Um, so that's an important thing, and we did see this macro before. I think it was in the C template. Not sure if I'm able to find it right now, but basically, what it basically boils down to is we have two magic numbers, and then we give the base revision, and the latest base revision is apparently 3, and this is here because uh, this way we can like check if the current uh, base revision we're asking for is supported by the actual bootloader. I'm going to quickly read some of the text here. Base protocol started. Apparently the revisions 0 through 2 are deprecated, so we're just gonna have to use 3. But mm, there was a line I'm trying to find. Bootloader not get support request space. No. Ah, okay. Okay. Using an yeah. So the way we check if the base revision is supported by the bootloader is that if the bootloader does support the revision tag, then it just sets this value to 0. So this line basically. On the other hand, if the executable's requested base revision is supported, the third component of the base revision tag, so this array, will be set to or must be set to 0 by the bootloader. So um, during load time, we will call this macro, and if at load time if at runtime if it is set as 0, then we basically the bootloader basically supports our revision. And another thing, mm, so we're wondering what these values were. It's apparently just magic numbers that the bootloader will um, yeah look through uh, to find the the corresponding marker. So and mm, no, maybe we don't even need that. But what this basically is that we can um, the bootloader will look through the memory trying to find certain magic numbers, and if we put these markers, I think we can just can be told to start and or stop searching for requests, including base revision tags, loadable images by placing start and or end markers. So if we put these magic numbers, then the bootloader will just stop looking for additional requests uh, values, and it identifies the request using certain magic numbers. So idea for yeah, scan. So in this example, the ID is the ID of the request, and it is an 8-bit alike magic number that the bootloader will scan for inside the image to find requests. Requests may be located anywhere inside the executable image as long as they are 8-bit aligned, and there may be only one of the same request. The bootloader will refuse to boot an executable with multiple of the same request ID. So we would use this delimiter when we want to, like, in order to avoid conflict. So if like our later the, the data in our executable, uh, to avoid like basically uh, conflicts with our data and this request uh, structures, we can request the bootloader to stop looking for those magic numbers. That way, we'll not like get conflicts. Entry and yeah, the and we did look at the linker file where we were specifying that the executable be loaded at this address, and that's apparently mandated by the protocol itself. Um, so it will set up some memory regions for us. So if we ask for a frame buffer, then the frame buffer will be mapped to one of these regions, I think. We don't need to look at caching. What's this it? So yeah, I mentioned that the bootloader will set up a lot of things for us, and one thing uh, the things it does set up is the global descriptor table. I think that's what it's called. Um, so it will set these up for us. But the interrupt descriptor table, so the interrupts, uh, interrupt handlers and stuff like that will be undefined, and that's where we can, so that way we can define our own interrupt handlers and or like do whatever we want with that. But and yeah, like stuff like opening the A20 gate, which I haven't fully understood what this is for, but maybe we'll like learn in the future. And it also supports booting through UEFI. which we'll do in our kernel. And let's see what else. So composed of four 64-bit on-site posture common to every request. So we can use this macro to specify these these magic values, and the bootloader basically will look for these magic uh, values to identify a request basically. And so yeah, if it is for so in the case of uh, if we need to like ask for bootloader info, we would include these two magic numbers, common numbers, and then maybe like this is probably specific to the bootloader info itself. So we can request for the firmware type, the stack size. Not sure what this is, but we can do that. So here is where we would do the request for frame buffer, and we would basically fill ID with fill this array with these values, and I guess revision would be the revision of the bootloader itself. So I think we can just use three in this case, or maybe two, or maybe zero. I don't know. And it will provide a response which will have these members, frame buffer count, how many frame buffers are present, and the frame buffer is a double pointer, which so first element of the frame buffers will give us a frame buffer basically. And so a particular frame buffer itself will have a starting address, width, height, and pitch, which is basically how many bytes are in one row or scan line. And there's a difference between, so BPP is how many bits are in each pixel, and so this frame buffer will be composed of pixels, and it will BPP will give us how many bits will be for each pixel. And I think since we use the um, RGBA, so red, green, blue, and alpha. I think A is for alpha, uh, and each would be 8 bits. With each value will consume a byte, so each pixel will be 32 bits. I think we'll check it later, but that's what I think. So BPP should be 32 in our case, and you might be wondering that isn't like pitch the same as like doing something like, so if we, so isn't it the same as doing where did it go? Yeah. So uh, how many bits are in each pixel divided by 8? So how many bytes in each pixel, and how many pixels are in say each row. And this may not be always true because um, there may be some padding uh, in each row that may be required by the hardware itself. So basically, I mean, I think normally this would be the case, but I think we cannot just assume that this is the same as doing this calculation. So I think that's why they do they provide us separate values. Mm, oh, I'm lost again. Where did it go? Yeah, frame buffer. Video mode, paging mode. So Then we'll also have a let me show this. Execute the control which basic mode is enabled before control is passed with uh, request request mode. So we can so these are the additional. So when we are doing a request for the paging mode, we can specify which mode we want and what is max mode and min mode. Mode is a preferred paging mode by the OS. Okay, the bootloader should always aim to pick this mode unless available, unavailable, or overridden by the user. Okay, and max mode is the highest paging mode in Limine Bootloader. Okay, and min mode would be so how many levels of paging that we want, and if we want to specify that at maximum I think we cannot go more than 5 levels, but like if we want to specify that at most try to do max 5 and at minimum try to do let's say 2, then the bootloader should like try to uh, set these limits basically. So these two would be the limits for what the bootloader will use, and this is basically the preferred mode. And if you don't do a paging mode request, then by default, I think it uses paging mode default, which would be mode default. 4 level. Okay, so by default, it uses 4 level paging for x86 64, which we care about. Yeah, and but it has support for 5 levels paging apparently, which is awesome. X86 64. Not sure what this is. Yeah, 64, blah blah blah. Hardware map features. Not sure what this is. There's not even any info. Bootloader number. Entry point feature. I wanna quickly check if my audio is working. Yeah, okay. It seems to be working fine. Okay. Entry point. Huh. So we can apparently. Awesome. This is cool. We can like specify what we want our entry point address to be. Okay, I'm going to have this not. No, module file structure. Not sure what this is. No. So yeah, we have support for UEFI. Okay, so I think that's all about the protocol. So last time we had this, and I think if you look at the code, we'll understand uh, this more properly now. Um, so yeah, we're doing the frame buffer request, and as for the revision, we're specifying 2, but I think we can go up to 3. And in terms of just a sec. Okay. So the the so we specified a request, so the bootloader will fill in a response, and if we get a response, kind of wanted to look at, yeah. So it is like just what we imagined. It checks. So in order to find out if the page revision is supported, we do this check at runtime, and the bootloader will clear that field. So we know that so that way we know that this is base revision is supported. Um, so yeah, the frame buffer response field will be filled up by the bootloader, and we basically get the first frame buffer that the bootloader provides. And in this case, so I mean, this was like uh, so we're printing a horizontal line. That means we need to, with each pixel, we need to move uh, down by, oh, move horizontally by 1 pixel. So with each scan line or row, we need to move. Also, we also need to be moving like uh, uh, pixels ahead to the right. So what we're doing here is for 100 times, this would give us so bits would be how many bytes um, in a single row. So we're skipping through the rows. So in the first iteration, would get the first row, and the next iteration we would be at the second row and stuff like that. And as for the column, we're stepping by uh, uh, a single pixel at a time. And since each pixel is apparently 4 bytes in size, we need to multiply by 4. And we're basically adding the pixel offset to this starting address, and then assigning this a hex value, which apparently gives us this color. Um, yeah, I think that is white. Yeah, which makes sense since FFF would mean white. Yeah. Um. Now my I couldn't release the mouse grab for some reason. So what I have done is I've created a repo 1b, and it should be public. Let me check. Um, OS 1b. Yeah, it. Oh, I'm logged in. I know that this is public because I did it, and I've initialized README and flight techniques, but everything else must be this should be the same. Uh, kernel. Yeah, so what I did was I just got rid of the frame buffer stuff and then added a in, which for now does which just does halt. But our goal for today is to get something like so if we have terminal that prints hello. So this is our goal, to be able to print some text to the kernel, to the screen. Okay, so I was cleaning up the Makefile a bit because, I mean, since I guess that is because I mostly copied stuff from other repos, but I kind of wanted to start over basically. So this is the new file that I have, and it's not complete yet, but I'll try to explain what we're doing. So I mean, you always start with like the entry point, and the entry point would be make run. So let's first look at the run target, and I've written that we're going to use OVMF, which is OVMF. Yeah, it yeah, it's a port of intensity and a core converter to the QME for yeah. We can use it to experiment with UEFI with QEMU. Provides a UEFI converter for QEMU. Yeah, QEMU. Is that how it's pronounced? But, okay. So we're going to use OVMF for for loading with UEFI support, and fortunately, Limine has support for UEFI, so we don't even need to do much. But so this would be the endpoint, and it depends on OVMF itself, and we need to download OVMF using wget. So I should now like I remember that I should specify that we need wget. Ah, okay, I've done that in here, but what about readme? Ah, okay, so all good, all good. So we're going to download to this location, and this has just like variables that I said. So OVMF dir would be this dir would be inside the this dir, and the URL would be this, and yeah, we're going to download the OVMF file to the this dir, and this is basically doing that, saying that we only so this is in Makefile terminology. This is called, I think, order only prerequisite. So this means that even if like this only specifies that we should run this target before we should make sure that this target is run before this this OVMF target. But if for some reason the timestamp of this directory is changed, then it's not a requirement that we rerun this target basically. So we're only specifying the orders and not the actual prerequisite. So that's OVMF. And as for the ISO file, we're going to we've specified that we're going to want this our ISO to be called os401b.iso, and there are some common QEMU flags which I've explained here. That's MQ35 specifies that the QEMU should use the Q35 machine model, which is apparently a modern Intel chipset, in the which so use the modern chipset rather than emulate the more modern chipset rather than the older PC model. We're giving it 128 megabytes of RAM, and here we're specifying that it should use the drive D, which is it should boot from the drive D, which is the CD-ROM, and here we're specifying the CD-ROM itself, and with QEMU we can specify an alternate BIOS to use, which we're going to uh, since we're using UEFI, we're specifying the BIOS to be this file, the OVMF file that we will download basically. And but um, also leave this option to use Lexi BIOS so that we can test in both environments. And as for the IS file, we depend on Limine. We definitely need that Limine to exist, and then we depend on kernel, which we haven't built yet, and there is an order only prerequisite for builder. So We just want to ensure that this directory exists. And yeah, here's the target. So that's the incomplete Makefile. So let's try to complete it. Um, so there are a couple of things that we need to do in order to build this, and I think we can just copy these steps, but um I kind of wanna reference. So there's another, where was it? Let's see. Yeah, kind of also wanna reference this because here's where we are also using OVMF. Yeah. Um. Yeah. So we need to copy over the kernel. We need to copy over the limine.conf. Okay, let's see. So we copy over the limine.conf to builder. Then we need to copy over the kernel bin. So let's where should we get the kernel? Since we're going to, so since our kernel is located here, I think we will have another directory called zigout, and then bin, and then kernel. So yeah, zigout, bin, kernel. So let's just kernel doors. I should specify a kernel doors first. There's the file. Yeah. Uh, uh, Tuck, 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 tuck. Okay, this is kernel. Kernel. No, kernel bin. Tuck, 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 tuck. And kernel. Figure out bin kernel. Okay. Oops. I didn't mean to. Just delete this buffer. Copy over the kernel bin. Kernel bin over to builder. Builder. And okay, so let's just deal with kernel first. Kernel. So this is simple. Yeah, zig flags. Let's just copy zig flags. Zig flags. Oh yeah, zig flags. Tuk, 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 tuk. Okay, let's save. Okay, zig flags. Go to the kernel and zig build zig flags. Yeah, simple. So this will ensure we have the kernel. Okay, let's specify this as a phony target. As for Limine, we need to clone that repo and basically do make. Okay. Limine. And where do we want to clone? So I think we should clone it at tester. Yeah. So we specify the order only prerequisite for tester. and we do so we need a uh, let me just copy this URL, maybe the entire, yeah, but god damn it, let's copy this URL. Okay, with clone this one and on the entire history, specify the branch v a.x, that's fine. Okay, and clone it over to the star limina. So let me just specify the limiter. What do I want to do that? Yeah, let's do it here. Limiter. Limina. Okay. Let's use limiter. Okay. So clone it here, and then to make. So we don't need to define this variable. It's just the make itself. So it will just mean make things. Denominators. Awesome. So we have the ISO file. So we will build Limina in the kernel. Then we copy over the limina.conf in the kernel. And then we need to copy over, what is that? This files. Okay. Mm -hmm. Limit bias as cd.pin and limit bias UEFI dash cd.pin. Okay, copy them over to builder. Then copy over. Okay, so we need to specify. We need to have this for the UEFI. Okay, let me check what the template had. No, not this one. Oof. Okay, if I put do we need to have that EFI? Okay, let me look over. So I'm trying to figure out what directories we need to ensure are present in order to, like, for this Makefile. Oh, okay. So as for UEFI, we can copy these files that can be copied to the EFI boot directory of a fat. Oh, okay. Okay. So okay. So we will need to create this directory. Okay. Where do we create that? Okay, I should EFI boot. In that case, EFI does. Let me create a target. If I it depends on, let's say, builder nature must be um builder by boot. Okay, so let's just do um, builder. Okay, so copy over the boot files. Nope, nope. Where was it? Okay, eliminator boot star.efi. So let's just do copy everything to efi there. Oh, I need to create this. Cut. Okay. This is going to be this, and yeah, you know what? Maybe just never mind. Copy it over to the folder, and then we do XOR ISO. Not sure what we're doing here. Okay. Oh, okay. So we're converting this. Let me just do a quick chat GPT. Because why not? Nope, nope, nope. I wanna be. How do I create a new private window? Yeah, Control Shift P. I was entering Control Shift P. I didn't it work? God damn it! God damn it! Come on, come on, come on! What the hell? What can I? Can I not even use ChatGPT anymore? What the hell? Let me try chatgpt.com. Hello. Okay. Explain this to me. Mm-hmm. The XOR ISO is used for creating ISO images. It's being used to create a bootable ISO, especially creating an ISO supports both BIOS and UEFI booting. Oh, okay. As MKI ISOFS still behave like the older. Okay. Compatible with older scripts. Okay. Boot related options enables rock trace extensions, which allow for long file names and unique style file permissions on the ISO. Okay, so this is what the R does. Recursive Juliet extensions, which provide support for long file names on Windows. Okay, so rock trace would be for Unix and Windows. Dash C, dash B, this, and boot image for BIOS systems. Okay. So this is for bias uh, bias system. No emul put that the boot image does not use emulation to be used for bootable CDs or DVDs for the boot image in a binary that is directly loaded. Okay, boot load size 4 sectors to load for the boot image. This is typically set to 4, which is a common value for bootloaders. I'm not sure about that, but for input table, that's the boot information table to the ISO. This is useful for bootloaders to understand what the boot table sectors are located. Okay, HFS plus support for HFS. Ah, okay. APM block size. Apple partition map, which is used for macro system. So we probably don't need these two options. Let's see. EFI. So we're doing the EFI portion here. EFI boot part creates an EFI partition. Okay. Boot image marks the file specified as the EFI boot image. Okay. So yeah, valid boot. Okay. Valid EFI boot image. Okay. A productive MS-DOS level protective MBR to the ISO image, which is necessary for creating ISO. Oh, awesome. Mm. Uh, Input. This is the directory, and the output file will be this. Okay. Cool. Cool. So let's just copy. Um, let me just copy over this file. Sorry, this command. Okay. 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 Now I'm boot, and so are these files relative to ISO, which in our case would be, I think, builder, because that's where we're copying the files. Yeah, I'm not sure, but and after that we basically need to do limine bus install and install limine to the ISO file. Okay, and where can we find limine? Inside liminator. Okay. Mm, mm, mm. Limiter boot limine. So register liminer and yeah, I think it's to bias install ISO file. ISO file. Okay. I think I need to specify the actual location for the ISO file. Let's just do builder, or should I? So where am I using this limiter? Oh, ISO file. Just here. Okay. I depend on ISO file. Okay, let's just specify the entire path. Why not? We'll see how it turns out. Um, so we do bias install. What? Oh, and then we can get rid of. Oh, okay. And then we can get rid of ISO. So in that case, let's not copy everything to build the. Let's do it inside ISO. Let's create a separate blah 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 blah. And we're going to use ISO. Okay. So let's do builder ISO. Awesome. ISO file. Okay. ISO. Specify target ISO. Yeah. Maker consider and with the page on consider. Okay, now we need to change a few things. We need consider. Copy copy it over to consider. Copy the kernel to ISODR. Copy the Limine files to ISODR. Copy this to EFI. Okay, and I think our EFI, yeah, it needs to be specific. I mean, it needs to be relative to the ISODR. So we change ISODR. Yeah, EFI. Okay. Yeah. So now our EFI depends on. Okay. Um, Isidore, EFI dot, yeah, this is fine. Minus a file and Isidore, okay, minus a file, and then we can remove the actual, because we will have an ISO file inside it, so we can get rid of, yeah, EFI dot, yeah, that is fine. Is that all? Run, we have clean, yep, we have clean, and I think that's all we need to do with regards to the Makefile. But kind of gonna test it out first. So let's copy over to Makefile.back and then use. I think I can make Can I do that? Yeah, seems like I can. Not sure. Oh, damn it. Build. What? What? I should. What do I have in build? So I removed. Okay. Now I think, but this isn't right. Build. Ah, builder. Isofile builder. Ah, builder isofile. Just do isofile. Okay. What? Ah, this Limine. Okay, so I get why we're doing Limine here. Let's try that again. Did that work? Not sure. Kernel, that's our kernel. Then, okay. So right now we don't have anything, but I kind of need to check if this even worked. Let me copy over. Get the frame buffer request. Let me get const and get the response and do this and do that. Yep, this should work. Make run. Let's see. Oh no, we're downloading. Nope, that did not work. But what? Did I not save that file? Okay. What? Need to make it run. I probably don't want to Makefile. Okay. Why are we downloading OVMF again? Okay. OVMF. What? Oh, it's inside. Scroll. Nope. Nope. Yeah. Makefile. OVMF. Okay. Okay. Um. So I think it's the same for this Makefile as well, but I kind of don't want to be downloading the OVMF every time. OVMF file. Okay. Let me just do. What if we do this? So I think in this case didn't download. Yep. Okay. We copied over this. So we have the kernel that has root. We have these files that has root. We have these two. So apparently we're doing a lot of files. Okay. We only need IA32 and yeah, it's 64. So don't do, oops. So I only need, come on, need this. And I only need that. Anything else? X64. No, I don't do, yep, that's fine. Do that. And when it's completed, as installed, yep, completed. Mm. Okay. I think we need to update our 0.5 with what? Why do I have what? Why do I have so many files inside here? Okay. Uh, mm, limiter. Okay. What is that? Limiter. It's inside test. So why the hell do I have so many? Just remove test and boot and then take boot and then take up and build. Yep. So let's try it. Get downloaded to OVMF file. And yeah, I think we need to modify this file. Okay, kernel. I don't think our kernel is, yeah. Where is our kernel going to be at? Kernel. It's going to be inside as a door, which is slash. So what if we do slash? Oops. So do we have, let's look at the previous file. So I think the Limine, our Makefile is good enough. Why is it not? Okay, the response. Okay, start. Then call make again. Okay, so it's working right now. What did I do wrong? No, not this way. Okay. What if we do flower? Not that same anything. Okay, so it's working now. Apparently, we shouldn't use const. Yeah. Uh, that's funny. In that case, we probably shouldn't also use const for this one. Awesome. So we have a proper Makefile now. Let's look at our changes. I don't need these things. I don't need this. Ah, I don't need the frame buffer request right now, but I do need this revision to be valid. So yeah, this three kernel did I make a change the right way? Okay. No, flip the next. Flip the next. Oops, I made alpha key. I should have done. But whatever. What should I do? Wait. And let's do this screen. Build just I need to add build as well as list. Yep. Oh, and I also need to remove kernel dir kernel dir kernel dir kernel dir. Yep. Oh, yeah. Inside that, we need to remove the check gas. Yep. Dot check gas check gas and jig out. Let's do it inside. Yeah. And enter jig out. Yep. Okay. So let's commit this. Uh, Let me remove the file back. Test. Yep. Okay, here comes the GNOME Makefile. Maybe I should just use Makefile. Yeah. Okay. That way I can like. Hmm. Not sure what commit message I should use, but yeah, sure. Why not? Let's push these changes. Let's use the main. Mm, Damn it. Okay. Oh, awesome. Yeah. So I think if we do a kernel, we should have. Well, right now it won't really do anything. If we do Micron again, yep, everything should be cast and super quick, right? Yep. I should have depended on, and I don't wanna do XORIS every time if these files haven't changed. But since we're like removing root every time, maybe we should keep it as it is. Yeah, sure. That was surprisingly a lot of that took surprisingly a lot of time. So I'm going to take a quick break and yeah, maybe maybe I should just do a second stream. We'll see whatever.